All right, let's dive right in. Today, we're talking about something that could, and this is not an exaggeration, completely unravel our digital world. We're not talking about a virus you can patch. We're talking about a fundamental shift in computing that's putting all of our secrets on a ticking clock. Just think about it for a second. Our whole digital life, from online banking and private messages to national security and corporate IP, it all rests on one single idea, that our encryption is just too difficult for any computer on Earth to crack. It's the invisible foundation of trust for everything we do online. And that, right there, is the core of the problem. A quantum computer isn't just a souped-up version of your laptop. No way. It's a totally new kind of machine, working on principles that are, frankly, kind of mind-bending. And it's a machine that's being designed to pick those unbreakable locks, and to do it easily. So, to really get a handle on this threat, we've got to first understand the locks themselves. What is it, exactly, that a quantum computer is going to break? Well, the security we rely on comes down to this really cool idea called a trapdoor function. Imagine this. With systems like RSA, it's super easy to multiply two giant prime numbers together. But it is practically impossible for a normal computer to take that resulting number and figure out the original two primes. That one-way street, that's the whole secret. And this isn't some abstract concept, right? It is literally everywhere. That little padlock you see in your browser, your company's VPN, every single time you buy something online, all of it depends on that mathematical trapdoor staying firmly shut. The stakes really couldn't be any higher. Okay, so we've got these incredible locks. But what about the key? Well, this new machine, the quantum computer, it's basically the master key that's being built to open every single one of them. This is probably my favorite way to explain the difference. A regular computer trying to break encryption is like trying to find two specific grains of sand on a beach by checking them one by one by one. I mean, it would take longer than the age of the universe. A quantum computer, on the other hand, it sees the whole beach at once. It analyzes the patterns of all the waves to tell it exactly where those two grains of sand are. It's not just faster, it's a fundamentally smarter way of solving the problem. And the specific tool that does this has a name. It's called Shor's algorithm. And get this, a mathematician named Peter Shor figured this out way back in 1994. It's the perfect algorithm to crack those trapdoor functions we talked about. So we've known about the master key for decades. We're just now getting close to building the machine that can actually use it. Now, it's really important to understand that not all encryption is in the same boat. For the public key stuff, the asymmetric crypto like RSA, the threat is, well, it's existential. Game over. They will be totally broken. But for symmetric crypto like AES, the threat is more tactical. It gets weakened, but we can fix that just by making the keys longer. So the real, hard, complicated problem is replacing our entire public key infrastructure, the whole thing. Okay, so you might be thinking, this sounds like a problem for 2035. I'll worry about it then, but that's where you'd be wrong. The danger has already started, and it's happening in total silence. It's a strategy called harvest now, decrypt later. Right now, adversaries, we're talking nation-states, are vacuuming up huge amounts of encrypted data. They're stealing it, they're storing it, and they're just waiting. They can't read it today, but they're building massive libraries of our secrets, patiently waiting for the day they can. This means every piece of stolen data is basically a ticking time bomb. It's just sitting there, waiting for what the experts call Q-Day. That's the day a quantum computer powerful enough to crack it finally comes online. And on that day, all that harvested data becomes an open book. So how do you know if you're already at risk? Well, there's a simple formula for it. First, ask yourself, how long does this data need to stay secret? Then, add the time it'll take you to upgrade all your systems. Now, if that number is bigger than the time until Q-Day arrives, then guess what? Your data is already vulnerable. I know, that all sounds pretty dire. But, and this is a big but, the good news is that there's a massive coordinated global effort already happening to build our next generation of defenses. We're not just sitting around waiting for this to happen. And you can see from this timeline just how fast things are accelerating. Just a few years ago, we thought breaking our standard encryption would take a machine with like 20 million qubits. But now, because of some amazing algorithmic breakthroughs, that number has plummeted, putting Q-Day squarely in the early 2030s, which lines up perfectly with the roadmaps from companies like IBM and Google. And this number is the reason for that insane acceleration.
Those breakthroughs led to a more than 95% reduction in the quantum bits needed. I mean, think about that. What was once this massive, almost theoretical scientific challenge suddenly became a much more achievable engineering problem. It brought Q-Day from a distant, maybe, into sharp, immediate focus.
So what's the fix? It's something called post-quantum cryptography, or PQC. And here's the absolute most important thing to get. These are not quantum algorithms. They are new classical algorithms. They run on the computers we have right now, today. They're just based on different math problems that we're pretty sure are tough for both old school and new school quantum computers to solve. And this isn't just a theory anymore. This is real. In August of 2024, the U.S. National Institute of Standards and Technology, that's NIST, published the first official standards. Algorithms with names like Kyber and dilithium are now officially ready to go. The starting gun for this massive migration has been fired.
Okay, so the solutions are here. How do we actually put them to work? I mean, this is a huge multi-year project for any organization, but you have to start somewhere. And the journey begins right now with some really clear foundational steps. Really, the path forward starts with 4 key moves. First, inventory. You have to find all the crypto you're using. You can't protect what you don't know you have. Second, prioritize. Figure out what's most at risk. Third, architect. Build your systems for something called crypto agility, which basically makes it easier to swap out algorithms down the road. And finally, educate. Everyone, from the boardroom to the developers, needs to understand what's happening.
And that first step, the inventory, man, that is a huge job. You got to look everywhere. Your public-facing websites, all your internal networks, your servers and laptops, inside your databases, and you even have to dig deep into your own source code, where old, forgotten crypto libraries might be hiding out. But here's the silver lining. This whole forced migration is a massive opportunity. Because as you're doing this deep dive, you are absolutely going to find and fix existing security problems, like expired certificates or weak algorithms that are putting you at risk right now. You're basically paying down decades of crypto debt, and you get an immediate security boost from it. Ultimately, it really all comes down to this. For years, the quantum threat was something to watch from a distance. But now, with standards in place and Q-Day getting closer and closer, the era of passive observation is over. The time for active preparation has begun. So I'll leave you with this one question to think about. Think about your company's most important data, your most valuable secrets. Is the encryption protecting them built for the past, or is it ready for the future? Because the time to answer that question is right now.